Whoops.
Points of this of this Allen-Cahn equation. This can be done by some standard minimax method, and then we let epsilon go to 0, and then by for example by Hutchinson Tonegawa, then we can get a minimal hypersurface. But here the problem still lies in the multiplicity problem. So when we let epsilon go to 0, the nodal set of U epsilon can still hold together, just like in the interface clustering picture. And so in this way, we need to show that the limiting minimal hypersurface is still of multiplicity 1. And this was proved by Chiotoshi and Manolidis in dimension 3. The rough idea is, the main idea is by looking at more closely at this clustering situation. So if we have two connected components of this transition, of the transition layer coming very, very close, then we need to look at the interaction between these two components. And for this one, we also need to get some distance lower bound of this one. And then we need to write it down in a very precise way, the interaction between these different sheets of these transition layers. And if we write down this one, we will see that because these two sheets are very close to each other. So and we expect these transition layers are minimal, at least approximately minimal hypersurfaces. And if we represent the second sheet by the graph of this fixed one, then this function by a graph of function y, then this function is satisfies the linearized equation of the minimal hypersurface equation, which is just the Jacobi equation. And then because that here we have shown that these transition layers are all smooth hypersurfaces, and they are embedded, so they cannot intersect with each other, which means that this function y is strictly positive. So we not only get a Jacobi field, it's also a positive Jacobi field. And then we know that if the linearized equation has a positive solution, then this critical point is stable. So eventually we show that if we have a clustering interface, or if we have two transition layers converging to the same minimal surface, then this minimal surface must be stable. Or equivalently, if the limit minimal surface is not stable, then this clustering situation cannot happen. So this gives the multiplicity 1. Okay, I think I will stop here. Thank you.